Hi, so my name's Daniel Bryant, and tonight I'm going to be talking about service meshes. Brand new exciting technology in the cloud native space. We're going to be diving into what is the technology, why should I be using it, and what kind of benefits does it have, and also what potential problems could it introduce as well. And I'm going to be summarising with a few use cases, if there's time, hopefully as well, which will demonstrate some of the things I've done with clients, some of the mistakes I've made, and some of the successes I've had as well.
So it's great when somebody does half your job for you. That's brilliant, thank you. Really great to be back in business after the summer. It's really great to see huge attendance here tonight. That's fantastic. So thank you very much to our great guests for coming along. Daniel's up first talking about service meshes, something we use. We have a homegrown one, so I'm really interested to see how someone does it professionally. And then we're going to have pizza about 8 p.m. or so. And then Steve and Graham are going to talk about cloud native Java. So without further ado, Daniel,
cool.
Please take it away.
Thank you, Richard. So thanks for the invite to Richard and Benito. It's my first time in Ireland, bizarrely. I live just outside London, super lucky, get to travel the world with some of the talks I do. First time in Ireland, so hopefully the first of many times, yeah. Tonight we're going to be looking at service meshes. It is very much a kind of 101 or introductory type talk. So just to set expectations, it's going to be quite high level. Are people generally familiar with the term service mesh? Istio, things like people bumping into that kind of stuff? I see a few nods, cool. So this will be a main sort of overview, some of my experience. I've been working with it over the last 6 months, I guess. And I'll share some of my learnings, some of my successes, some of my failures, kind of give you an overview of what I think the tech could be used for. And I've only got 40 minutes and I mustn't speak too fast as well, which is one of my challenges. So I'm going to start by framing this stuff. Cloud native is a thing, in case people sort of haven't really bumped into it. Buzzwords are buzzwords, I know, but I find sometimes we say DevOps, we say cloud native, it does help us group together certain ideas, certain practices, certain principles. Cloud native, public cloud, containers, microservices, event-driven systems, these things seem to be coalescing in what we're calling cloud native. And obviously microservices, this is the microservices meetup, you're all fully on board with kind of microservices. And cloud native is very close. Service meshes have kind of evolved from some of the communication challenges with cloud native tech, with cloud native architectures like microservices. So with cloud native, the kind of pitch here is a bit different, I think, from the marketing kind of spin than perhaps we actually get when I'm assuming many of you are developers, architects, engineers, QA. You're actually in the trenches, you're coding, you're testing, these kind of things. But the pitch, I think, is very much this. We have our business problem, we create some services, we cut it up, we put it into containers, we ship it, and it's good to go. The challenge is many of us are dealing with tire fire problems. We've got old legacy money-making apps. We've got apps that talk to each other in bizarre different ways. And if you try and put these kind of apps into containers in cloud native, what you actually get is literally tire fire in a container. And you'll notice the fireman at the bottom there. This is what in our industry we call as DevOps. And this is how I make my money as a consultant or in the UK and Germany and also in the US as well. I like to give TLDRs. I like to give basically a 30-second, 1-minute pitch of what I'm going to tell you tonight, and then waffle on for 30 more minutes, saying the same things pretty much. But this gives you a kind of idea. The service mesh is really a dedicated infrastructure layer for making service-to-service comms safe, reliable, kind of observable, monitorable, and configurable. It is also increasingly being used around messaging as well, but primarily it is around point-to-point RPC, remote procedure calls. And it's a dedicated sort of layer. I've seen challenges before service meshes, and I've worked with service meshes, and they've overcome some of these challenges as we move from what I'm going to be calling complicated systems, monoliths, SOA, that kind of stuff, to complex systems. And I'll break down what I mean by complicated and complex in just a moment. But as we move into microservices, particularly if your application is composed of a lot of microservices, I'm sure many of you know the sort of operational complexity in particular. There's the architectural complexity, breaking stuff up, but there's also the operational complexity. Just chatting to Connor before, around how do you observe these things, how do you kind of network these things together. These are big challenges. Kind of shiny tech warning. Yeah, this is kind of a new technology. Service meshes have only been around, I guess, a year or so. It is kind of a similar pattern to things like ESBs. Anyone's used enterprise service buses? Everyone sort of recalls, with horror enterprise service buses. I've done my time on some of those. Some ESBs are great. Some of the more traditional ones are quite heavyweight. They encourage you to spread business logic around and so forth. So service meshes are kind of similar to that tech with a few different nuances. This is me, so I'm an independent consultant, as I say, based out of the UK. I work with DataWire as well, hence the t-shirt here. They're a Boston-based startup specializing in open source tooling for Kubernetes and cloud native tech. So no product pitches tonight, hopefully. I will mention a couple bits of tech I'm working on, but it's all open source, so you can download it and check it out. I also write for InfoQ, so I love doing sharing interesting news. If any of you have got interesting use cases, interesting stories you want to share, hit me up afterwards or hit me up on email. We might be able to get you published on InfoQ as well, because I love sharing people's stories. I started as a Java developer. Java is my native language, as I say, in terms of coding. I'm very lucky with Abraham. We're writing a book. It's literally just been finished, Continuous Delivery with Java. That has been a crazy experience, but it's been a lot of fun. And hopefully that one will be out. It'll make a perfect Christmas present for yourself or your partner. Doesn't matter if they're not into code. Makes a lovely sort of doorstop as well, or a monitor it brings. But it's about 450 pages of hopefully useful stuff. It's been a journey writing that. Anyway, enough about me. Setting the scene. So I mentioned about complicated and complex tech, and I'll just walk over to the screen. Apologies, this might be a little bit small, but I started my career sort of coding around the 1990s. Yeah, very much in vogue then. Monoliths, single language, in-house hardware, data centers, all that kind of thing. 2000s was when I went to uni. I really got sort of started in the coding then. We were doing a bit of SOA. SaaS was becoming a thing. Amazon famously kind of did the AWS thing around 2006. SQS, S3. A bunch of things kind of changed from here where we were developers. We sort of moved from specialists to generalists. DevOps became a thing. Cloud emerging. And as we moved even more into the 2010s, where we're at now, we're very much around decomposition of functionality. Microservices, function as a service, serverless, SaaS, all the things. We're moving towards dumb pipes and smart endpoints, HTTP, Kafka, gRPC, all this good stuff. And two things in particular, cloud and containers, very much a thing now. We are kind of, with things like Kubernetes, treating the model as data center as a computer. We just look at data centers now as homogeneous blobs of compute and memory, and we kind of carve them up as appropriate. Yeah. Everything is software defined, in particular networking. Very much SDN is a thing these days, and when you're deploying onto the cloud, everything you're pretty much doing outside of the CPU and memory is going over the network. I made a bunch of mistakes when I first started coding for the cloud, developing on my laptop, then pushing that code to the cloud, and suddenly the performance of block stores is massively different. I suddenly realized this. Massively different. On the Mac, everything's over a local bus, super high bandwidth, then you push to the cloud, and then, particularly when I was doing this in 2010, I think it was, the block store performance was massively different on Amazon than it was on my laptop, and I made a few crazy errors there with a few bits of code. We've kind of moved through here, yeah? And if anyone's familiar with the Cynefin model, a sort of model of complexity, and I'm going to totally abuse the model, but the Cynefin model talks about how we kind of make sense of the world. And there's this kind of simple domain, and I'm going to kind of argue that back in the 90s, things were a lot simpler in terms of architectural and operational complexity. I was working with a monolith. If something went wrong, it was the monolith, yeah? I was working in a single language. I had typically sysadmins, ops teams to manage all the in-house infrastructure. These systems, I think, are complicated. There's more moving parts, but I could reason about it. I could understand. It's coarse-grained SOA. Usually I had my boundaries, maybe 10 services, a few WSDLs, all this kind of stuff, but I could reason about it quite well. As we're moving across here, we're making a big jump. So simple, is what it is, simple. Complicated, simple with a few more sort of cause and effect relationships. complex is a whole new world. Yeah? Everything's blurring. Now a full stack developer is almost expected to do ops, database, front end, back end. It's super confusing, yeah? It's actually very complex. And as we're breaking things up, we're kind of pushing the complexity around. Microservices don't really hide the complexity. If anything, they expose the operational complexity, yeah, of the software. So as we're moving through these things, just to complete the model, this is chaotic. Here be dragons. You don't want to go here if you're familiar with the Cynefin model, but ignore that for a second. We're kind of here on this one, and this to me is the kind of cloud native space we're working in. Yeah? And for tonight's talk, the most important thing really is everything is going over the network if you're using cloud. Yeah? And I don't know, people bumped into the 8 fallacies of distributed computing? Yeah, brilliant, let's see a few hands. It's totally worth a read. I'll put a link there for you as a Distributed Computing for Youngbloods article. I completely fell foul of this back in 2010, I guess it was, whenever I was doing cloud stuff. There was a bunch of us coding on an application in London, and we were using Amazon, and we assumed all our networking would be reliable, there'd be no latency, etc., etc., etc. Yeah, this is words to live by if you're building a distributed system. And the kind of news flash is any cloud native system is a distributed system. Microservices in particular are distributed systems. Yeah. So all these kind of golden rules here really apply to cloud native software. The general approach I see in my consulting travels, and it's a massive journey and it's obviously very anecdotal. As a consultant, you only get called in when stuff's on fire. Yeah, so you see bad stuff. But it's very anecdotal. But in general, and I can relate to this because I've done it, people's approach to this is very much this. Yeah, we'll just kind of forget about this stuff. Don't worry, it'll come out in the wash, as we say. But you can't. It's quite hard to test for some of these things. Now, cloud native communications. I don't know if anyone's bumped into Christian Poster's work, but I'm going to totally stand on the shoulders of giants. Christian, awesome gentleman, met him a few times, based out of Arizona, I think, in the US. He's just doing some amazing thinking. I'm going to steal some of his ideas. You can Google them later and have a look. But in particular, he was saying that cloud native communication is when we're deploying on something like Amazon, Azure, Google, Kubernetes, whatever, the services are communicating over an unreliable network. If you've used Amazon, you've seen it. Yeah, stuff works like one way, not the other. You get split brain, you get packets dropped, you get this bizarreness happening all the time. The interactions, particularly in a microservice system, are often non-trivial. Once you go past the kind of 10 service mark, a lot of kind of complexity there potentially. But there is clear value in understanding the network. Architecture, there's always a static view. You've got the nice UML diagrams or nice C4 diagrams of architecture, but there's always a dynamic view to that architecture. And the dynamic view is often more important. So we need to understand how all these things work together. The application is ultimately responsible. This is definitely something to take away. Some people I see using service meshes are trying, as they do with many other different technologies, they're trying to put all their worries, all their risk onto a technology. I can't deploy stuff correctly. Let's put it all in Docker. Docker will handle it for me. I'm seeing kind of the similar, these communications in the cloud are complicated. I'll just spin up Istio. It will handle it for me. It does to some degree, but ultimately your application has the business logic to handle the errors. Yeah, that's really, really important. If something, you've got a bunch of microservices and then something down the chain breaks, there's probably a business rule that says how to handle that. Should you continually retry? Should you put something in the queue, process it later? Or should you show the error to the user? Your application, your business context is critically important, and service meshes don't wash that responsibility away. Just a heads up, and I've seen a few people and I've been there as well on some of this stuff. And we have been here before, even with the technology. Yeah, don't know if anyone's tried to do RPC with queues. Classic thing I saw back in 2000, I think it was. Trying to do ActiveMQ, RabbitMQ, trying to separate sort of time and space of services, but doing RPC, so it's a synchronous call going on over here, but you're trying just to push the complexity of some of the operational challenges into the queue, basically. Done that one. ESBs, and Christian, this is Christian's graphics, not mine. Kudos to Christian. Got this, we called it the magical bus, the enterprise service bus, and you kind of had all these services you built, and the services just threw the communication onto the bus. or as I like to say, they threw it under the bus, yeah, pretty much. And not only was the ESB a magic box, of, black box, you're not sure what's going on, but business logic got smeared between your services and the magical ESB as well. I did a presentation called The 7 Deadly Sins of Microservices a few years back, and I was seeing at the time the same thing even with API gateways. People were pushing their business logic into the gateway as well as their actual code. And in particular, if you have people are using the Netflix OSS stack, Zool, very interesting front edge proxy, very cool proxy, but it was very easy to do bad things with it. You could slot in dynamic functionality, which Netflix did very well, but Netflix are Netflix, yeah, we're not all Netflix. And I saw many people trying to make their lives easier, but coupling their applications with the technology. And it was really hard to deploy and release code. So we've made a bunch of mistakes, we've probably learned a few good things as well. Now is the time to kind of reflect on some of these lessons. And again, standing on the shoulder of giants. My sort of academic past always taught me to stand on the shoulders of giants and look around at what other people are doing. Phil Calzado, I'm sure many of you bumped into Phil's work, it's an awesome work. He's talked about how service meshes have evolved over the last few years. Great article. I mentioned that the Netflix OSS stack. Now I'm sure many of you have bumped into Hystrix, things like that before, and various sort of Spring Cloud does the same if you're a Java developer. What we were seeing was a lot of this functionality, excuse me, around handling network failure, retries, circuit breakers, timeouts. A lot of the functionality was being pushed into language-specific libraries. So if you're a Java shop, running Hystrix is great because it's a Java app. You bring it in as a library using Maven, using Gradle, you're good to go. The only snag was, what happens if you then want to introduce Python into your stack? You've got to recode all those things in Python now. And I did a Ruby project in particular, and there were subtle differences with the Ruby implementation of Hystrix versus the Java implementation of Hystrix. So we didn't have the same transport guarantees in terms of circuit breaking and fault tolerance. So we kind of did that. We did these libraries, then we kind of realized we actually want to have our business logic here, and we want to split out some of this cross-cutting concern. Some of the retries, some of the circuit breaking, maybe things like mutual TLS, mutual transport level security. But we still want to have the networking stack. The networking stack is quite nicely isolated. gRPC, queues, HTTP, for example. And this is kind of the evolution from libraries, language-specific libraries, to kind of standalone libraries, to what we're now calling the sidecar pattern, where something is running next to your app. Your app is talking to that sidecar, and the sidecar is doing all the kind of responsibilities at the transport layer. So it's handling retries, it's handling circuit breaking, it's handling even service discovery. And your app talks over a secure channel to the sidecar, and it doesn't really know, it knows it wants to talk to service B, but the sidecar handles all the kind of operational complexity around the communication. And this, basically, at the moment, a popular one I'll talk about is called Envoy. It seems to have taken the world by storm. But I'm sure many of you, or a few of you at least, have looked at things. NGINX did this pattern for a while. NGINX called it the fabric pattern, the fabric router. I think fabric router, sorry. So there's a bunch of proxies, HA proxy, a bunch of proxies in the past that have done this model, but it's really taken off with the thing called Envoy, which comes from the Lyft engineering team. So that's the kind of history, and just to kind of really put it home, when we talk about service meshes, there is two parts. There's the control plane, which we'll look at in a minute, and the data plane. The control plane is how we as engineers interact with the tech, and the data plane is that basically takes our instructions and realizes them at the code or the network layer level. So control plane, maybe a UI, config file, communicates somehow to this data plane, which then does all the magic in terms of actually routing stuff. And we'll look at that in a minute. So the service mesh, so to speak, as a concept, sits kind of in the middle. If you imagine this is an NGINX diagram, but there's microservices here. This kind of in the middle is your service mesh. Yeah. Christian's done a nice diagram, like here, he's got his services, something here like a sidecar in front. This in the middle is kind of the mesh. I've seen people do like north-south type diagrams as well, and they've got like, particularly if you're using things like MuleSoft, they often have hierarchical levels of microservices. So you have like a sort of a UI type microservice or an input cleaning microservice, a view almost. You have maybe like some sort of service level or business functionality level, maybe some DAO or repo type microservices. I'll let you decide whether those are good patterns or bad patterns, but I've seen this quite a bit. But the service mesh sits in between the services. It's the thing when you're communicating from a service to another service, it goes through the mesh. And if you're like sort of inclined in terms of the OSI model, the service mesh basically sits at layers 5 and 6 of the OSI stack. It also implements or touches layer 7, so a lot of the service meshes can look into your HTTP traffic, can look into your TCP traffic. So they can do clever things by they're kind of context aware. They can look at the headers in your HTTP request. They can look at the if you're using Mongo at TCP, they can look at some of the instructions in TCP to do clever things. It also touches layer 4, because layer 4 is kind of your actual, like your load balancing kind of layer, but they primarily sit in levels 5 and 6. So that's kind of like where meshes are at. Yeah, let's just start on there. So that's kind of a, what is service meshes? Are they kind of concept, how they've evolved, why we need them, complexity. They've kind of evolved. A bunch of unicorn-like companies like Google, like Facebook, like Netflix have created functionality in libraries, and then they've realized the pain as they've moved towards more languages, pulling out these kind of these cross-functional concerns and putting them into sidecars. So now let's spend like 10 minutes or so looking at functionality, and then that might be a nice sort of moment to pause. But the key functionality you can get with this service mesh pattern is it normalizes naming and adds logical routing. I'll break all these down in separate slides, so don't worry as I whiz through them. You can do things like traffic shaping and shifting, so you can kind of modify where traffic's going to on the fly. Load balancing, you can basically deploy a service into the cloud or into Kubernetes and not route traffic to it until a later point, so you can use them to kind of control deployment and release. And you can also shadow traffic. So if users are making requests, you can shadow these things off and maybe like do some experiments with the kind of requests, but you can also run some tests, which I'll show you in a minute, without actually impacting the users what they're seeing from making the requests. It adds baseline reliability, like I showed you, as in it does it can do retries, it can do circuit breaking, those kind of things, outside of your app. So me as a Java developer, I need to understand what these things are offered to me, but I don't, no longer do I need to worry so much about putting retries in my code. And I've written a bunch of complex code over the years that had circuit breaking, retries, all crazy different logic. Now I can do, my code is generally a lot simpler because I make a business logic decision as what to do if there's an error, but the service mesh handles a whole bunch of this stuff for me. Yeah, out of process, out of my code, which is quite nice. You can do cool things like the security. One thing, I did microservices kind of like 2012, I think was the first project I worked on, which was kind of microservicey with hindsight. And we really wanted to have TLS, MTLS, between services. Yeah, we had SSL coming into the app, but we wanted all our services to communicate over SSL, over TLS. And we just couldn't do it at the time. Certificates were too challenging. But service meshes, because the kind of sidecars sit next to your services, next to your app, they can handle all the things like refreshing certificates and setting up mutual TLS. So this was the first time I actually ever got MTLS working in a microservice system was through the use of service meshes. Observability is a key thing. As we're building more and more complicated or complex systems, we need to understand that dynamic runtime. We've got our static architecture, but we need to understand what code paths, what services are being executed at runtime. Yeah, particularly if you've got an application with a lot of services. Things like request volume, success rates, latencies of each service, but increasingly we're seeing things like distributed tracing. A whole bunch of companies popping up now like Lightstep, Honeycomb, offering really nice UIs and even sprinkling in some AI because the VCs in San Francisco love a bit of AI and machine learning. But they're doing some really cool things with, you can basically trace a request through the system. So a request comes into your ingress point, it might get fanned out, multiple microservices handle it, and you need to trace basically and correlate all those different requests to understand what is happening. And yeah, there's some really cool tech going on. Honeycomb and Lightstep are really cool bits of tech actually. but service meshes are a cross-cutting, a way to implement this cross-cutting concern of observability without peppering it through your code, which is nice. And chatting to Matt Klein, who runs the Lyft team, one thing that really stood out to me that Matt said is people, all the Lyft engineers have got kind of freedom and responsibility. They can write lots of code, they can push lots of code, but they use Envoy, they use a service mesh, and what it does is it actually acts as a kind of sandbox around their service. So if their I write a new service, I deploy it, and if it's causing lots of 500 errors, HTTP 500 errors, or if it's doing other crazy things, Envoy can actually shut it down, can isolate my service. So the Lyft team use it as a kind of gatekeeper. You can override the actual, all these configs, freedom and responsibility. So if you override it, you've got to be responsible for what you're doing. But it's a nice way, I can just kind of deploy stuff, and if it causes other services to go mad, I know there's going to be some kind of protection. Yeah, it's quite nice. Right, let's run through some of the naming and the load balancing stuff. So again, apologies, this might be a little bit small, but in the application, you can often refer to a service by its name. So user service. And the service mesh will handle all the kind of conversion from user service into where it actually sits. If you're using a cloud, it might be sort of a VM. If it's Kubernetes, it's a pod. Particularly in cloud-native environments, it's quite ephemeral. Yeah, things get shut down, things break. There's constant movement of your services, so IP addresses don't really mean much anymore. You want a logical name. I just want to talk to the user service. The mesh can handle where that actually ends up for me, which is nice. And because every request is going through these sidecars, I make a request, sidecar handles it, it can do really smart things around load balancing. So if I've got, say, 3 instances of the user service, and one is returning a lot of errors, one is really latent, and one is actually performant, the mesh will know that by inspecting what's going on. Linkerd, Envoy, a lot of the meshes, it's a built-in thing, and it can send my request to one of the services that is not overloaded. You can kind of do smart routing, quite nice. Oh, that's exactly what I've done. Sorry, I talked through there. You can do things like traffic control. So we'll break down a bit more of these things later on, but say I've got service A here, and I want to talk to service B here, and I've got a new version of service B. I'm not sure if it's going to work, so I only want to route. Sorry, I've been in America for a lot of time there. Route, it's really confusing. Route. I only want to route, say, 1% of my traffic because I kind of want to canary in the coal mine. Yeah. If I route 1% of my traffic here and this service blows up, or the response back here is not very good, then I can can that service, throw it away, do some more refinement. But with service meshes, you can literally apply those rules. You can say, because my service A will talk out through my sidecar, so it says I want to talk to service B, 99% of requests are going to go to this one, and 1% of requests are going to go to the new canary, which is quite nice. That's pretty much what I've just said there. So this is just a bunch of examples. I've taken this from Kelsey Hightower. I'm sure a few of you bumped into Kelsey's great work. He's got a really nice tutorial. You can even do interesting things around the routing based on headers. So you can only route that 1% test. We can say I only want to route iPhone traffic, for example. You can inject an arbitrary amount of headers. Maybe it's just me doing a test. So I make a request that says, test header Daniel. And I only send 1% of my traffic here if it's got that header. You do a bunch of because you've got that sort of layer 7 awareness, you can do a bunch of smart things by using HTTP headers or gRPC headers, those kind of things. And that's pretty much, that's the link to Kelsey's tutorial there. So you can grab a slide deck, have a look. You can also do per request routing. So we're doing a bunch of this stuff with DataWire at the moment. So you can kind of, like I mentioned before, with headers, you can do fun things. You can say if I'm working on this service here, all the normal traffic in production can go to the genuine real service. But I can inject a per request header that says Daniel's test, and when it gets to this point, it will route to my service. So if things like telepresence, anyone's bumped into another DataWire tool, telepresence allows you to basically proxy your machine into a Kubernetes cluster. So it's an open source tool, you can check it out. I find it super useful. I can be coding on a Java service locally, and it's as if I'm in the cluster. due to a two-way proxy. It actually replaces the Kubernetes pod with the proxy, and then the proxies to the traffic to my machine. But I can basically make requests against production. Everyone else is routing through to production, doing their normal things, all good. But my requests going through to production hit my test service. I've got to be super careful about what I do with data stores, obviously in production, things like that. But when I'm doing like prototyping and stuff and working with very early stage startups, this allows people to go very fast. They're literally coding against production. Yeah. And you've still got CI/CD pipelines for deployment. You do experiments here with shadowed traffic and so forth, but then you push everything down a pipeline for safety. Very kind of funky stuff. You can do wiretaps as well. That's the thing that the Linkerd folk quite a bit. They put wiretaps on so they can see what's going in between two different services to do debugging, which is quite nice. Timeouts and deadlines, I'm not going to say too much about that, but you can basically push the responsibility of handling timeouts into the mesh. So no longer in your code are you saying, looking in headers and doing timeouts and stuff, the mesh can handle that for you. You can do things like circuit breaking. I sort of mentioned this already. If one instance of your service is under load or is breaking or is garbage collecting in Java or something, Stephen Graham will cover all that in a minute, but you can basically have a circuit breaker at the networking level. So if the service mesh detects that one service is under load, it can trip the circuit. No more requests will go to that service that's having a hard time until, say, like 30 seconds later or a minute later, and then the circuit closes again, traffic flows there. If it's still broken, the circuit will trip and so forth. Just a heads up, this is not like Hystrix. This is not application level circuit breaking, it's kind of networking level, but you can combine it with things like Hystrix. And Hystrix kind of gives you fallback options. So you can, if you are noticing a service is under load, you can fall back to something else. But this is purely network level fallbacks. I mentioned MTLS already. Very nice. This is actually from an old version of Envoy, old version of Istio, sorry. But you can see we've got two services here. This is your kind of mesh. There's proxies or these sidecar things. My services are, every bit of communication is going through the proxies, Envoy in this case. And Envoy is being managed by something up here, which is rotating certificates. So there's guarantees, both like client and server side guarantees. You know who you're talking to. And everything over here is going via TLS. Everything's encrypted, which is quite nice. Particularly, there's something called zero trust networks, which is becoming more of a thing at the moment, where these things actually might be cross data center. So you might be going over a wide area network here, or the internet or something. So having this kind of mutual TLS between services guarantees encryption. And also on that note, there's lots of interesting space. I've put this slide up more as a reference, but there's lots of interesting work going on. HashiCorp in particular, I'm sure many of you bumped into HashiCorp. They do amazing work. They've got Console Connect, so they've extended their console product into a service mesh now, and they're doing a lot of cool stuff around security policies. Can service A talk to service B? Can the right user only talk to various different services, these kind of things? So there's lots of interesting work, and a lot of it is focusing around what's called OPA, which is a kind of way to define, in a very service-friendly way, security policies. Rather than using things like IP tables, firewall rules, anyone who's done any Amazon kind of networking config, you've got NACLs, network ACLs, you've got security groups, SGs, and they're a nightmare to figure out. And a lot of these things, not only are they a nightmare to figure out, because they're dynamic, it's quite hard to program them. Whereas basically the service mesh can do a lot of that stuff for you. And by using a kind of, and this is totally too small, but it's kind of a DSL describing at a logical level what kind of security policies we want. Service A can talk to B, service B can only talk to D, various things like this. Very, very fun stuff. And OPA is kind of I believe it's a sort of CNCF kind of sponsored thing, like a Cloud Native Computing Foundation. So I think lots of interesting work is going on in this space. So add an additional layer of security. Big thing with service meshes is because every bit of communication is going via these sidecars, via these proxies, onto the mesh, we have visibility into what's going on. And Istio talks about this a lot, one of the meshes, but you can do traces, so you can kind of understand the dynamic structure of your call graph of various services. You can do distributed tracing, Zipkin, Lightstep, all this kind of thing. And you can also do top-line metrics like latency, throughput, all these kind of things. Because everything goes through the mesh, it doesn't matter if you forget to put the code in. So I've had a bunch of projects where we're working on, and someone would misconfigure a service, so that service wouldn't report metrics. So you have like a dark area in the app. Whereas the sort of mesh, you kind of get it without trying. Yeah, I deploy my application, because it talks to other services through the mesh, I get this stuff kind of for free. And I use that term for free, because this stuff's hard to get set up. But once you set up, you get it a lot easier. Yeah, I've gone through basically the key ones there. So just as a kind of whistle-stop tour, there's a bunch of new interesting technology popping up. Some old technology as well, that if you're interested in this space, you might want to pay attention to. Envoy, we'll talk a bit more about in a minute. It is kind of the de facto proxy effectively now. NGINX are doing a bunch of interesting work in this space. They've actually hooked up with Istio. So Istio is kind of like a control plane for controlling Envoy in Kubernetes, in fact. But both NGINX and also Linkerd have got integrations into Istio. So Istio is a good sort of jumping off point. Bunch of interesting stuff popping up. So Linkerd has sort of merged with Conduit, another technology. HashiCorp are in this space, and wherever HashiCorp are, I think there's always interesting stuff to be seen. And Cilium is very much a lower level form of service mesh. It actually uses something called eBPF, which is kind of like kernel-based code. So whereas a lot of these things run in user space, Cilium stuff runs in kernel space, so it's much faster, but it's arguably more complicated, more complex to get working right. But I think probably Cilium is where the direction of things are going, because sometimes with with apps with high demands on performance, doing all the things I've described add overhead. There's extra network hops, there's the service mesh is doing extra things. None of that stuff comes for free. So although this stuff is really nice sort of prototypes of what's going on, you can argue that Cilium is probably more where the technology is going to end up. It's going to be pushed into the platforms, so we as developers don't need to worry about it too much. It's great to understand it. I always say as a developer, work on mechanical sympathy. Yeah? Always try and understand one level down from where you're working. So as a developer, if you understand how cloud works, you'll write better code. As a QA person, if you understand how cloud works, you'll test things more effectively. So I always try and encourage people to look sort of one level down, and the service mesh is probably going to be a thing. So it's a good idea to be looking at what's going on there. To be honest, there's so many things. So if you're doing the HashiCorp stack with Nomad, for example, instead of Kubernetes, but thanks Verizon created Nelson. So check out Nelson if you're using Nomad. eBay have got their own thing called Fabio, which is interesting as well. Allegedly, eBay are actually moving to Envoy now. So a lot of these big companies have been using what we're now calling service meshes for many years. Just as many companies were using microservices before it became a thing, these companies, kind of for me, it's almost a proof point. Yeah, we're not all Verizon, we're not all eBay, we're not all Netflix, but they are finding some value out of these technologies. So it's probably useful for us to look at it, but you can argue that it's going to be pushed into the platform anyway. So kind of we have to understand it. So I mentioned Envoy. So Envoy is Lift Engineering wrote it. It's a super high performance C++ bit of kit. It's an open source proxy. The config is a little gnarly, how you sort of configure it up, but it is a really well-designed proxy, a really well-designed data plane that we can kind of push all our traffic through. There's that seems too small for me. There's a bunch of interesting work. So Envoy is becoming almost the default API, and apologies, I can't even see the name, but there's based out of China, I think it's Alipay in China, they're doing some fantastic work. They've rewritten Envoy in Go. I'm not sure why, but they've taken the Envoy APIs, so you can argue that Envoy now is becoming kind of the definition of how the data plane works, how the proxy works, and that's C++ implementation, but Alipay have created their own Go implementation if you want to do a Go version of things. Edith from Solo has created Glue. So Glue is a kind of Go-based wrapper on top of Envoy, doing more API gateway-like functionality, and she's looking a lot at doing serverless kind of functionality. So again, Envoy's driving all the comms, but this is a different control plane onto Envoy, a different way of using the tech. Shameless plug, but with DataWire, we're also doing something called Ambassador. So Ambassador's more for your API gateway stuff again. It's effectively a wrapper around Envoy, all the cool stuff with Envoy, but it's in a simpler package because we're only dealing with north-south traffic. We're not looking at the internal east-west traffic. We use basically Kubernetes annotations. We've got some CRDs coming, some other stuff coming down the line as well. But we seem to see very much that this Envoy kind of tech is kind of where microservice communication is going. We're going to be routing stuff through something, and it's probably going to be Envoy. All the big cloud vendors are working on Envoy now. GKE have got a hosted Istio with Envoy available now, I believe. AKS are working on this stuff, Azure, and we believe Amazon, AWS, are working on Envoy tech as well. So, kind of like it or not, it's probably going to pop up on our radars fairly soon. I'm getting pretty close to time now. So, putting it all together, so Istio is probably something you'll bump into first. Istio is kind of the control plane. As I mentioned before, it's where we as developers, QA engineers, interact with the tech, and the proxies are the actual things that do the work, so to speak. Yeah. In theory, the proxies are swappable, and we have now defined sort of a nice API on Envoy, so you can swap the data plane, swap the proxies out, but Matt Klein makes the point that Istio is actually built, it was Lyft, Google and IBM, and they built Istio with Envoy in mind. So if you're going to use Istio, probably best, even though other vendors may tell you otherwise, probably best to stick with Envoy. This is literally, probably should have put this one up earlier, but this is a kind of example of the control plane, data plane thing. So this is the control plane up here. This is where I'm interacting. I'm maybe running a CLI command. I'm chucking in some config, and they've kind of done the single responsibility thing. There's 3 components. One handles the service discovery, one the telemetry, and things like that. This control plane communicates down to our sidecars, our proxies, which our services are communicating through, and handles all the kind of magic. Yeah. And it also takes all the telemetry. So these envoys are kicking up telemetry to the control plane. You can distribute this control plane, so it's not a bottleneck, but they're sending up telemetry, and then you can graph all these kind of decentralized, services, decentralized proxies. You can graph it, you can interact with it via a sort of centralized control plane. I'll skip over, that's just an Istio breakdown. These are the different control planes. So there's what's called Linkerd is another version of a service mesh. They exclusively control it via the command line. They don't have any kind of UI stuff. NGINX are totally on this space as well. They've got some interesting command line tools, and they're also building, I think it's called the controller, which is a kind of UI for understanding your service map and mesh, and actually sending commands down to the proxies. So a lot of interesting development is going on in this space. I think that is pretty much it in terms of, I'll skip over a few things there. If you want to get started, I've shared the slide deck, but I'll put it up on my slide share. Bunch of interesting articles that I found really helpful when I was learning this stuff, some videos I watched, and I don't know if people have bumped into Katacoda. A friend of mine in London runs that. It's basically it's a way of experimenting. So it's that you can do everything via the browser. You can spin up a Kubernetes cluster kind of in your browser. It's all that's Docker behind the scenes, and you can basically experiment with Istio in a low-risk environment. So I love Katacoda. I do most of the stuff's free, I think, on Katacoda, and I'm constantly playing around on Katacoda to understand stuff. So kudos to Ben Hall. Shout out to Ben Hall for doing Katacoda. So it's a nice way. I think so. I've got basically a bunch of other slides. I've done this talk a few times. I'll share all the slides, so there's some use cases there, and there's some other things you might sort of be interested in, so where I think it's going in the future. But I'll kind of wrap up, I think, at this point, and just reiterate what I mentioned at the start. I appreciate it is quite a lot coming at you. My goal was to give you a high-level taste of this stuff and just get you thinking, and you can always come chat to me afterwards or do some more reading. But really, the mesh is sort of becoming a new layer in the cloud stack, and microservices, cloud down here. Becoming a new layer in the stack that manages all your communication for you. Yeah, and it's good because we can push a lot of stuff that we're currently having to put in our code. We can push it into the platform to some degree. Your application is responsible for handling business failures, but you can kind of get rid of some of the language-specific kind of issues, and you can push it sort of down into the platform by using these sidecars, these proxies. It is a good way to sort of homogenize basically all the kind of RPC and potentially messaging. If people are looking at putting service meshes as messaging as well, it's a good way to have this homogenized fabric for communicating on. We're moving, like I mentioned, from sort of complicated monoliths and so on to the orchestration of what I'm thinking are quite complex systems. I've got some microservices, I've got some serverless, I've got some SaaS in there. There's a lot going on, multi-cloud, all these different kind of things. I find systems I work on now quite hard to understand. And I think things like service meshes can provide the kind of hooks for understandability, observability, testing, debugging, these kind of things, yeah. Heads up, it is a new technology and implementing an old pattern. So I'm working with a bunch of clients that are using like Linkerd or Linkerd 2 now, I guess, and experimenting with Istio, but they're doing so knowing the risks. Some of this stuff is changing really rapidly, particularly Istio went through a whole bunch of changes recently, and some of the clients I was working with, their kind of proof of concept got to a stage and they almost had to start again because all the APIs and everything changed, which was kind of a bit awkward. So if you're not really struggling with your communications, maybe keep an eye on it. It's kind of where it's going, but make the judgment call. Yeah, do you want to spend your hard-earned time and just hard-earned money as well playing around with some of this stuff? Particularly, do you want to spend your hard-earned time playing around with it in production? I think it's super interesting. I think it's where the industry's going. I think it's definitely worth paying attention to what's going on, but maybe don't jump into production with it just yet. Final shout out, as much as all the mistakes you see, if there are any tonight, are mine. A bunch of people helped me put this stuff together. Massive shout out to Williams, Owen, Christian, Matt, Sharam, Lewis, Run, and many, many more people. When I started doing this stuff about 6 months, a year ago or something, I was a bit lost, and I had to learn a lot. And only could I put this deck together over my experience over the last year by these people helping me out. So massive shout out to them for kind of guiding me through some of these challenges. We've got so I write for InfoQ, free service mesh emag. So I've deliberately tried to put this together to help people that are new to service meshes. It's free to download. We do need your email. That's how we kind of make our money with advertising. But I hope this is useful. Let me know if it is. Let me know if you want any kind of more stuff in the future like that. You can grab that one via the link. And at that point, I shall pause, take a breath, and say thank you very much.